Well, dear my students, I come here with new video, and in this video I will derive the fringe width. Before I go to this experiment, I have told you what is the meaning of monochromatic source of light, coherent source of light, how to obtain coherent source, and how the intensity of light become maximum when two waves of same frequency, same amplitude superimpose each other while traveling in the same direction. So many things I have discussed in last videos. So one experiment was performed by Thomas Young, in which he was able to obtain fringes from two narrow sources like this, and he was able to measure the wavelength, and he established the wavelength. He established the wave nature of light. Light has wave character. That is established by this interference experiment. He performed the experiment, and the line diagram is given in NCERT book here on page 363. Here is a slit, as I have shown this, and these are two slits here in the screen. Light from the two incident on this plane, and the fringes obtained are of this size. This is the shape of slits of width. These are the shape of fringes obtained in interference pattern. Please see it. Now, I simply want to derive fringe width here and to tell many things. I have here S1 S2 are two narrow sources which are illuminated by monochromatic source of light emitting light of wavelength lambda. The two slits become two monochromatic sources. Why? By phase in every source, single source. If we have any source of light is emitted in changing phase. I told you why. So whatever change of phase take place here, the same take place here. Actually here Thomas Young took sodium light. Sodium light has two wavelengths, 5890 angstrom, 5896 angstrom, which are nearly the same. Here OP screen at distance capital D from the plane of two slits, S1 S2 small d, and point O lies on right bisector distance S1 S2 and equidistant. Light waves going from S1 and S2 to O travel equal distance, and equal distance means they meet there with path difference 0, and propagation delta phi equal to 2 pi upon lambda into delta x. Delta phi becomes 0. Why? Because delta x 0. So wave from source S1 S2 meet in same phase. Please, dear student, don't get confused. Every wave travel in straight line. I have shown like this. In fact, in our NCERT book also, actually the diagram has shown like this, wave going like this. Please forget this thing. This gives very wrong idea. What is wave character with the light wave is that it consists of oscillating electric field, magnetic field. I told you what is wave, है ना? Periodic variation of sufficient quantity which is transfer energy. To varying electric field produced this way. Light travel from S1 S2 to illuminate the screen at point O. They meet in same phase, produce maximum intensity. And the fringe obtained at O is called zero order fringe or central bright fringe. P is any point physical distance x from the central bright fringe. Now, actually, you see from diagram, P may be this side also. You don't need to very lame. So here in this figure, PS2 is longer than PS1. So to find the difference, what we have done here, we take PS1 radius cut PQ. So PQ equal to PS1 to S2Q. S2Q here, what you will say S2Q? It is the path difference between the light waves reaching at P from sources S1, S2. Initially they are in same phase, so when we move from O to P, the phase change because of path difference. Delta X. This is here delta X in one sense. When light wave meet at P. So here I will find this P very simply. This distance delta X, very simple. So please, in figure we have got every point. You can take the help of book to describe, or you can listen my video by pausing the video again and again. If you want to describe, X is the monochromatic source of light which illuminates two slits S1, S2. Light from S1, S2 meet at O, and at every point O is equidistant, so they produce maximum intensity or a bright fringe. This fringe at O is called center bright fringe. P is any point at distance X. Since capital D very much greater than small d, so कितना अंतर होता है? कैपिटल D is of certain meter order, 1.5 meter or 1 meter, while small d is of fraction of millimeter. It is in fraction of millimeter. Please. So if D, since D is very much larger than small d, so angle S2 S1 Q, angle S2 S1 Q is equal to angle PMO is equal to theta, and this theta angle theta is very small, and I have told in at many places that when theta is small means small, very small, एक बात है, then थीटा इज इक्वल टू साइन थीटा भी होता है, इक्वल टू टेन थीटा भी होता है. फ्रॉम फिगर साइन थीटा हियर परपेंडिकुलर अपॉन हाइपोटेन्यूज के लिए 90, ये 90 नहीं है, बट कंसेप्ट हियर एंगल इज इक्वल टू आर्क अपॉन रेडियस. दिस इज आर्क, दिस इज रेडियस, तो इट इज S2Q अपॉन स्मॉल d. tan theta from this angle, triangle PMO is equal to X upon capital D. In books, actually, even in NCERT book, they have taken the help of Pythagoras theorem, binomial theorem, not required at all. But assume that these angles are small, assume that these angles really small. And when angle theta very small, then theta equal to sin theta is equal to tan theta. So from here you get S2Q is equal to X capital X, S2Q is equal to X into D upon capital D. S2Q is path difference. S2Q is path difference between the wave when they meet at P, going from S1 S2. Now if point P lies on nth bright fringe, then S2Q means path difference plus minus n lambda. Minus क्यों लिया? Point P here, then S2 S1 P become longer than S2P. Or n equal to 0, 1, 2, 3, 4 period of time. And if point P lies, then also we assume X equal to Xn. Then putting the value of Xn and S2Q is this. So we get n lambda is equal to xn d upon capital D, or xn is equal to n lambda capital D upon small d. When I ask the student what is xn, they feel trouble in explaining this. Here xn is the distance of nth bright fringe from central maximum. Please, xn क्या है? Distance of nth bright fringe from central maximum. Now, if point P lies on a dark fringe, I will take it as mth. अब इसको रखें, ये इक्वेशन 1 लिख लेते हैं. If P lies on mth dark fringe, then S2Q will be 2m minus 1 lambda by 2. Using x2q this and x equal to xm. ये 1 यहाँ लिखो और ये 2. तो ये वैल्यू यहाँ यूज किया हमने तो क्या मिलेगा? 2m minus 1 lambda by 2 is equal to xm into small d upon capital D, and hence from this xm is equal to 2m minus 1 lambda capital D upon 2d. Here m is equal to 1, 2, 3, 4. Why not taking 0? Actually 0 order तो हमारी central bright fringe है. When S1 S2 are emitting light in same phase. तो first fringe after that will be obtained dark fringe, है ना? Minimum intensity, तो इसलिए बदलिए हमने. तो this is equation 3. Now, as I have shown you diagram between two dark fringes, there is a so here I got two things. Xm, distance of mth dark fringe. What is xm? Distance of mth dark fringe from central maximum. Okay, और xm distance of nth bright fringe. Now, तो मैं इसको यहाँ लिखता हूँ xm. xn is equal to n lambda capital D upon D. These are also very important relations. Lot of problems comes on these two formula. Now, we know here between two consecutive dark fringes there is a bright fringe, and between two bright fringes between two bright fringes there is a dark. Dear student, I can't control this outside noise. It continues here. So how to find out width? And therefore, width of a bright fringe. I write with W. It will be xm plus 1 minus xm. Indicate difference of distance of m plus 1th fringe and mth fringe. Suppose 10वीं और 11वीं 10th 11th fringes dark है, उनके बीच है ये. तो now here I have used m plus 1 in place of m only. So if I use here m plus 1, so what will be xm? X plus 1 here. m 2m plus 2 minus 1. So we will get here 2m plus 1 into lambda d upon 2d or minus xm xx. 2m minus 1 lambda d upon small d. Here what is common? 2d, sorry. So or w is equal to lambda capital D upon 2d common 2m plus 1 minus 2m plus 1. So it's left here lambda d upon 2d are into 2. 2m cancel. So width come out to be lambda d upon small d. This is the width of a bright fringe. This is the width of a bright fringe. Now the width of dark fringe क्या होगी? Width of dark fringe W again, that will be xn plus 1 minus xn. Xn, what is xn? Distance of nth bright fringe. Say distance of fifth fringe bright at distance of sixth fringe. Difference of fifth and sixth fringe will give you the width of a dark fringe. So using n equal to n plus 1 here, we get n plus 1 into lambda d upon d or minus n lambda d upon d. This is new topic for you, so don't get afraid. Simple mathematics is being used. So lambda d upon small d common n plus 1 minus n. Again we get this w is equal to lambda d upon d. Means width of dark and bright fringes both are equal. Width of dark and bright fringes are equal, and the width of fringe also does not change with number. We get all fringes of equal width and equal intensity. My dear student, you have to understand the meaning of intensity. I have told you many times. Brightness maximum होगी तो वहाँ we say bright fringe is there. Brightness minimum होगी, least होगी, वहाँ we say dark fringe. So we get here four things. Distance of nth dark, nth bright fringe xn from lambda and lambda d upon d. Xn equal to 2m minus 1 lambda d upon 2d. Lambda is the wavelength of light being emitted from source S. Capital D distance of screen from the two slits. Small d distance. And width of fringes lambda d upon D. Numericals come there. Actually here problem is that wavelength will be given in angstrom, d will be given in meter, small d in millimeter. So we have to put, while solving the problem, all things in meter first and then solve. Now one thing more here, dear students, 20 minutes away. If the whole apparatus of young experiment is dipped in a liquid like water, then what will happen? Capital D same. Then if apparatus is dipped in liquid of refractive index N. So we know wavelength will get changed, the width of the fringe will be lambda dash d upon d. Wavelength of light change, you know, n equal to c upon c dash. C is the speed of light in vacuum, c dash speed in medium, and I have explained you when light goes from one medium to another or get reflected, there occur no change of phase in, there occur no change in frequency, wavelength changes. So nu lambda upon nu lambda dash. So n equal to lambda upon lambda dash. If I divide this equation by this, or this by this, I get w dash upon w is equal to lambda dash upon lambda, or lambda dash upon lambda is equal to 1 by n. 1 by n. So w dash is equal to w by n. So this way we get the width of the slit when the whole apparatus is in liquid. Now in next video, just coming here, just after this, I will be telling how to calculate the angular position as well as angular width of fringe in coming video, and how does the intensity of light vary with distance. तो same रहता है. I will discuss in next video. Thank you.